Okay, hello ladies and gentlemen. This is me again with a new episode of our programming series. Um, let's do a short recap where we left off. Last time we made some code to authenticate over SSH, and we got it to the point where it crashed because it asked for some setlib like this. So I googled a little bit and I found this. This is in the source code package for libssh, and here are some requirements listed. CMake obviously is is nur. Sometimes a German word escapes me. CMake is only required for building it. I downloaded some binaries, so we don't need that. But we need OpenSSL, and apparently, even if it's marked optional, apparently we need setlib. Windows binary known to be working. Two are listed here. I did not use them. I think I used those, but I googled and used a slightly different source than those. And here are some build things. We don't need that because we're not building. We're not building it ourselves. We're using binaries. So what I did is I downloaded this stuff and I put it in here in the debug. So now we have some more DLLs lying around here. And now we shouldn't have a problem. What I'm doing right now is I have an old Novak Piccolo chess computer. It's an 8-bit chess computer from 1985. I got it as a child, as a toy, and I played quite a lot with it. And then I put it in a box on the attic, and now I just brought it from there, and now it plays against Fritz. The Novak is playing white, Fritz is playing black, and the Novak is taking forever because I put it on the highest difficulty setting, and I put Fritz on the artificial elo rating of 1074. And I'm very curious to find out who is winning, which machine will win. So this is running right now in parallel while I'm doing some programming stuff. Okay. Yeah, let's get back to programming. I just noticed an error. Okay, what I did, I killed my server instance, made a new server, this time an Ubuntu server, because I realized that while FreeBSD is my favorite operating system, most of the chess engine I wish to try and test with later are easier to install on Linux compared to FreeBSD. And the second thing is I created a new key with a new password, just because I leaked the password earlier for the other key, which is not a problem, but I also leaked the file containing the private key, and those in combination would allow any user to log into the server. The server also has a new IP address now, so I should be safe. But just to be sure, I removed the IP address from here, I edited my etc hosts file, changed everything, and now everything should be fine. So let's run the program. What? Nope. Okay. It's not compatible. Why not? It should be. Oh, now it is. Okay. Oh. Okay. So apparently we have an issue here. Let's find out what's wrong. Okay, nothing until now. Okay, so this fails. And this fails with a message of invalid private key. Yeah, I think I'm an idiot. Okay, a callback function works like this. You give a pointer to that function, the function meets a certain signature. Then the other code does a lot of stuff and gives some parameters to the function. And it gives an already initialized buffer with an already existing size to that function. So if I do this, I make a local variable. And I think when this function loses focus, this is no longer accessible. So I think when I just assume that the buffer already exists, that the memory is already allocated, and I just copy the thing, then it will work much better. So let's kill the program and start it again. Yeah, okay, we don't need a breakpoint here, so let's try. Okay, I think this is good, because I think now we are inside of our still existing hello world loop. Oh, excuse me. My chess computer just made a move. As I said, it takes ages to make a move, and it will lose on time, almost certainly. I put 90 minutes in there, and 30 seconds for every move. But this is apparently not enough. Okay. So let's try to find out what's going on now. We exit here. And then we make a short Google and find out Ubuntu or Linux. Let's Google for Ubuntu. Show logged in users. Who? Print information about users who are currently logged in. So, okay, root is logged in and no one else. Meh. Okay, we are connected, we are authenticated, but it does not show that we are logged in. Yeah, maybe because everything happens here, and when I leave focus of that function, then bad things happen. So let's try it like this. And stop it and start it. Nope. Oh, no. Yeah. Okay, maybe this is incomplete, so let's try something else. Whoops. And see, oh, looky. This is very good. This is very good. So we have process SSHD up used by chess engines. So let's try now, and why do I have two command windows open? Let's try and do this, and now they're gone. Okay, excellent. What we have now is, let me show you. This is an SSH key. It's in authorized keys on the server in the home folder of the user's chess engine. I have the same key inside my working directory of the chess engine, of the chess tunnel program. My software is importing the key, asking with the callback function for a password, then it's decrypting the key and doing a user authentication. And then it waits for input and does nothing with the input. So the next thing we are doing is send the input to the session and get everything what comes from the session. So main page, the tutorial, opening a remote shell. We already mentioned that a single can be shared between several channels, can be used, etc., etc. This chapter shows how to open one of the channels and how to use it to start a command interpreter on a remote computer. The SSH channel new function creates the channel. It returns the channel as a variable of type SSH channel. Once you have the channel, you can open a session. Once you don't need, you can send an end of file to it with, at this point, etc. Okay, we have interactive and non-interactive shells. The non-interactive shell is similar to the existing. There's no attached terminal. If you plan using an interactive shell, you need to create a pseudo terminal on the remote side. Okay. If needed, you request, then you define its dimensions. Okay. Be your session interactive or not, the next step is to request displaying the data sent by the remote computer. Sending user input to the remote computer. A more elaborate way to get remote using graphical applications on the remote side. Okay. So I think I'm not quite sure at the moment if we really need a interactive human user typing the commands thing. Maybe it adds some unnecessary overhead, but for me it seems to be the easiest to get something running. So let's try. If you only need to execute a command on the remote and you not need all that complexity. Okay, the thing is I do not only need to execute commands, I also need to have a channel where I send commands to the standard input of the process invoked by this remote command. But first of all, I need to make a move. This is the beeping sound you might hear. And so I moved my knight to here, and then the computer responds with an illegal move, but only because, oh no, because I mixed up my pieces when I set it up. But it's a legal move. No, okay. Let's go back to this. And let's get to make some sense out of this documentation. It's good documentation. It's only my, the complexity is not really high, but also not really very low. So I need to wrap my head around it first. Request exec, that sounds good. If you can get them with channel read, if there's no more data, if an error has, etc., etc. Yeah, I think as long as this is running, I can send repeatedly data to the channel. For example, like this. Okay, what is this? What is this code doing? It makes a buffer. It declares an int. It reads things into the buffer while it's greater 0. And if okay, I don't really know what fret does. Let's find out. Yeah, okay, I need to look it up in the API. I know what it does, but I don't know what the destination and what the source is. Okay, this is for PHP. This is the right one. Writes a block of data to the stream. So pointed to the array to be written, and this specifies the output streams. So in the sample code, it writes the buffer to standard out. Okay, and if the write is not possible and not the bytes received are the bytes actually written, then we return with an error. And then we read the next chunk of bytes, and we do this all the time. And how do we get out of this loop? If no more data is available, we get out of this loop. But I would imagine this happens pretty fast, because we read everything and yeah, then we are done, basically. Yeah, okay, let's try this. Let's try this like it is. And take our program and put it in right here. Okay, we have to have a channel. So this is the thing we can do like this. Yeah, most of programming is just copy and pasting. Yeah, not really. Because once the real work starts once everything is a little bit in place and has some basic functionality. And once this is achieved, then you have to restructure it and do all the fine-tuning, and then it's no longer important to know the precise API of all these functions, because your cases and all the error cases are already working. So, and then it's a lot less copy and paste. But right now, how much time did I spend? If I did not comment it and just worked like focused on the project, maybe less than 2 hours. now I'm slightly over 2 hours. So this is completely normal for if you do some digging around with a new library, with a new technology. It's getting a feel for it. Okay. Are we waiting for output now? Could very well be. I think we are still logged in. Yep, we are. But normally, I would imagine that we get some kind of welcome message. Yeah, like this. And I would expect that I get this in the output, but apparently I don't. And I'm also at the moment not in this loop, because then the cursor would move. So I think I am in this loop. Yeah, let's try to find out. Let's set a breakpoint here. Oh no, apparently not. I don't really know what's going on. So let's set a breakpoint here and restart the process. Kill it. Go for it. Okay. Okay, we are inside this function. SSH channel read. So let's try something. Okay, on FreeBSD I can just type wall and a message and it will print the message. It does not seem to work this way. Okay, how are we going to tackle this? Okay, my chess computer made another move. Let's do it. Okay. I'm not analyzing this game right now. I will analyze it later on with more powerful engine running to find out where the chess computer makes good moves and bad moves. But right now I'm really curious how this thing here works. Okay, I think our channel is different from a channel where I would see a welcome message, because I think the welcome message is dependent on the shell. So for example, you have to open like bash or something like this to actually get the welcome message. So let's try this, and then we wait for the response, and then we see what happens. Okay, this is where we open a new channel. Yeah, I think I need all of this. This is already defined, declared. Then this is okay, if channel equals null, then return an error. No, we return -1 because -1 is our global error. Then we open a session. If the session is not okay, then we free the channel and return -1. Once the session is open, yes, I know that now. Okay, then we want a list of files. Then if it's not okay, we close the channel and return -1, and then we wait for the answer of that. Okay, let's see if that works. Oops. Yep. Ta-da! Okay, this is pretty good. Ha! This is very good. So this is the same thing as this. Now this is pretty amazing, actually. This is pretty amazing. Okay, so let's wrap it up for today. What did we achieve? We installed successfully a RSA key on a server. We set up a server. Don't even try to connect to the server. I will not take it. I will not take it if you try to. I get like, if you set up a new server that has the RSA port open, you get like hundreds or thousands of login attempts from China. So I filter all these because I'm not really interested, and they are only doing like with brute force any login that works. They are not attacking me specifically. But if I get a very focused attack from a European or US American IP address on that, then it will show up in my logs, and then I will decide what to do with it. If you are somewhere where it's difficult for me to file a case, then you will probably get away with it. If you are in the US or if you are in Germany, then I might actually take some action. And so please do not. Yeah, oh well, do it, and then you have one of my boxes on a cloud server, and I will shut it down sooner or later anyways and set up a new IP address and a new box, because this is has a hourly cost. So I don't think this will be very persistent on this IP address. So okay, yeah, go ahead and try if you want to. Okay, we installed a key, and then we modified our program a little bit, and now it has no longer 86 lines of source code, or 87, because that was when we started, but it has 123. It's a real clusterfuck now, like dog's breakfast. Error handling equals 0, code niceness, like here some random white space, is not very nice. Yeah, it's a clusterfuck. It's a real clusterfuck, but we got something to work, and this is sending data to the machine and getting an answer back. Okay, that's it for now. For the next tutorial, no, it's not really a tutorial. For the next video, I will have the chess engine installed on the server, and I will try on that on start. That this is, I will read this password and all the authentication from an authentication client until next time, like Pagent or something like this. I will have the executable set up so that it starts automatically the chess engine on connect, and then I will try to get the input that I type here forwarded to the chess engine and all output back on this console. Yeah, this is the idea for next time. Thank you for watching, and hopefully see you next time.